This video discusses how to replace the product and the quotient rules of differentiation using the natural logarithm. For this discussion, there are some prerequisites. We have seen how to differentiate the natural logarithm x with respect to x. We saw that this is equal to 1 over x, where x is greater than 0. And then we saw how to differentiate the implicit functions of the natural logarithm function, which means if I have to differentiate natural logarithm f of x with respect to x, d by dx, natural logarithm f of x, we proved that this is equal to, in the denominator you have f of x, in the numerator you will have f prime x, where f prime x is the first derivative of f of x and f of x should be greater than 0. And finally, we saw how to do the implicit differentiations using the natural logarithm function. That means basically we saw how to differentiate natural logarithm y with respect to x, d by dx, natural logarithm y. We saw this is equal to 1 over y times dy by dx, where y is greater than 0. We are going to use these three results in the derivatives that you are going to see today. In addition to these three results from differentiation, you will also need some other things from college algebra. That's about the properties of logarithm. All the properties of logarithm that you have studied under college algebra are equally applicable even for the natural logarithm. So let's quickly revisit those properties. The properties of logarithm. Here's the first property. Let's say you have to obtain logarithm to base a m times n, where m and n are both positive quantities. They may be functions as well. This is equal to logarithm base a m plus logarithm base a n. That's your first property of logarithm. The second property is about logarithm base a m over n, m divided by n. This is equal to logarithm base a m minus logarithm base a n. The third property is logarithm base a m raised to the power r. This is equal to r times logarithm base a m. And there will also be a fourth property which is called the change of base theorem, which I do not need right now. Therefore, I'm not going to write it at this point, but we will use it later when we differentiate the logarithmic functions which are written using the bases that are other than the natural base. In college algebra classes, you have seen these three properties and also you have seen the proofs of these three properties. Therefore, I'm not going to prove these properties in this video. Instead, I will directly apply these properties and these three previously proved results from differentiation to do the examples in this video. In fact, I will simply discuss one example and that should suffice you to understand how can we use the idea of applying the natural logarithm to both sides of a given function and thereby how to replace the product and the quotient rules. Of course, the product and the quotient rules are going to be a little bit tedious if your function is a somewhat complicated function. Let's say we need to differentiate the function y equals 5 square root x squared plus 3x plus 5 raised to the fourth power, all of that's divided by 3x squared plus 2x minus 1 raised to the 3/5 times 5x plus 1 squared. We need to find dy by dx. This function looks really complicated. Of course, we have a numerator and we have a denominator, which means we need to use the quotient rule. When you use the quotient rule, we know that we have to differentiate the numerator and also we have to differentiate the denominator in various different places. And if you look at the numerator and denominator respectively, we have a product in the numerator and also we have another product in the denominator. So in the places where you differentiate those functions on the numerator and the denominator, you will also have to apply the product rule. So this question is really complicated if you do not use the natural logarithm. What I'm going to do is, I'm going to apply the natural logarithm for this function for both sides. So let me write, take natural logarithm from both sides. Of course, in order to obtain natural logarithm, your right-hand side should be positive. Each term on the right-hand side should also be positive. When that is the case, the y should also be naturally positive. That has to be assumed as given in the problem. Alright, now what I'm going to do is, I'm going to take natural logarithm from both sides of this function. On the left-hand side, I will have natural logarithm y. On the right-hand side, natural logarithm. And then all of this term, let me copy and paste that. I would like to have that in red. All right. Now let me write this term inside big brackets. And now I'm going to apply the properties of logarithm and simplify the right-hand side. Please note that simplifying the right-hand side will not give me the dy by dx. But simplifying the right-hand side will make the life easy when it comes to dy by dx. So we will later do the differentiation. But at this point, we are going to simplify the right-hand side using the properties that we have seen from the logarithm. Because these three properties we talked earlier are for any base. And we can apply these properties even if your base is e. The natural logarithm means the base is equal to e. So using those basic results, how do you simplify this equation on the right-hand side? Of course, on the left-hand side, I simply have natural logarithm y. And on the right-hand side, I can see that this is 5 times the square root times all of that. So the numerator terms can be written as natural logarithm 5 plus natural logarithm square root x plus natural logarithm all of this term. The terms on the denominator should be identified as the terms that are used to divide this numerator. So this term should be written with natural logarithm with a minus symbol. And the same holds true for this term as well. So let's apply those properties and simplify the right-hand side. When you look at the terms on the numerator, I can see it's going to be natural logarithm 5 plus natural logarithm square root x plus natural logarithm x squared plus 3x plus 5 raised to the 4. Those are all positive terms because they are all on the numerator. And we have two terms on the denominator. Those must be written with negative symbol. Minus natural logarithm 3x squared plus 2x minus 1 raised to the 3/5 minus natural logarithm 5x plus 1 raised to the second power. Now we can simplify this right-hand side further by applying the third property of logarithm. The third property says these exponents can be written up front like that. The 3/5 can also be written here. The 2 can also be written here. In fact, the square root x can also be identified as x raised to the 1/2 power. In that case, that 1/2 can also be written here. So let's go ahead and do that simplification and write down this equation one more time. On the left-hand side, I simply have natural logarithm y. On the right-hand side, the first term is just natural logarithm 5. That plus the second term, I'm going to identify this term as x raised to the 1/2, and that 1/2 will be written up front and natural logarithm x plus. With the next term, the 4 will be written up front times natural logarithm x squared plus 3x plus 5. With the next term, minus 3/5 natural logarithm 3x squared plus 2x minus 1, with the last term minus 2 times natural logarithm 5x plus 1. All right. Now we can quite easily differentiate both sides of this equation. Please remember, we are going to differentiate with respect to x. So when you differentiate the left hand side, L and y differentiation with respect to x is equal to 1 over y times dy by dx. Please do not forget the dy by dx, because it's about implicit differentiation of natural logarithm y with respect to x. We are using the chain rule. On the right hand side, the first term is natural logarithm 5. If you differentiate that with respect to x, what's your answer? Natural logarithm 5 is a constant. Any constant differentiated with respect to technically any variable is equal to just 0. Therefore, there is no contribution for our answer from natural logarithm 5. Then we look at the next term, 1/2 times natural logarithm x. 1/2 is a constant, which we will just write as 1/2. The derivative of natural logarithm x with respect to x is just 1 over x. So we are done with that first term. Now we will look at the next term. You have 4 times. Since 4 is a constant, let me write down that as a plus 4, and then I need to differentiate natural logarithm x squared plus 3x plus 5. Please note that when you differentiate a natural logarithm f of x, that f of x as it is gone to the denominator. On the numerator, we write the first derivative of f of x. So when I do that, in the denominator I will have x squared plus 3x plus 5. On the numerator, I need the derivative of all of that, which is 2x plus 3. Please note that I wrote it down inside parentheses because there's a 4 right here which should be multiplied. Always it is safe to write down such derivatives within parentheses when you have more than just one term. Now we will look at this term right here. We have negative 3/5, so let me write that down first, negative 3/5, and then I need to differentiate this function. Just like earlier, I will write down the derivative of that function this way. In the denominator, I will have 3x squared plus 2x minus 1, and on the numerator, I simply need to differentiate this part. When I do so, I will have 6x plus 2. Now we have to do the last part. There's a negative 2. Let me write down that negative 2 times I need to differentiate natural logarithm 5x plus 1. When you differentiate that, we will have 5x plus 1 in the denominator, and then I need to differentiate the 5x plus 1 to write on the numerator, which is equal to just a 5. Alright, now we can simplify this and subject the dy by dx. In order to subject dy by dx, all I have to do is just treat all of these terms as one big factor on the right hand side and multiply that factor by the y, because on the left hand side I have a 1 over y, which I need to multiply onto the right hand side as a y. Then I can subject dy by dx. Or in other words, what I'm doing here is I'm going to multiply both sides by y. Then I will have dy by dx on the left hand side. That should be equal to y times all of these terms inside the brackets. The first term is 1 over 2x plus the next term is 4 times 2x plus 3 over x squared plus 3x plus 5, and the next term is negative 3 times. From this also I can factor out a 2. If I factor out a 2 from that term, it will be 2 times 3x plus 1. That 2 should be multiplied by the 3 right here. So everything will be simplified to become negative 6 times 3x plus 1 on the numerator, that divided by 5 times 3x squared plus 2x minus 1, and then with the last term I can multiply the 2 and the 5, and it becomes minus 10 over 5x plus 1. I will close the brackets. This is the final answer for that problem. The y right here, if you like, you can replace it with the given y originally in the problem, which is all of that. However, writing that y and replacing it right here is actually not required because y is already defined in the problem. Therefore, this can be accepted as the final answer. If I didn't use natural logarithm for this problem, it could have been extremely challenging. By the use of the natural logarithm, we could save plenty of time. Alright, I will stop this video at this point. If you have any questions, please feel free to let me know. Thank you so much.